All right, example 1, lesson 32. It says simplify the square root of 3/7. What I want you to recall back from Algebra 1 last year, because we dealt with these problems already, is you're going to split this into the square root of 3 on top over the square root of 7 on the bottom. And the word simplify always comes down to why isn't it simplified? If you know the answer to that question, you know how to fix it. The issue here is we don't want to have radicals in the denominator of a fraction. So square roots in the denominator are going to be illegal for right now. Right? There's certain scenarios in higher level classes where I let it slide, just for the sake of it being so ridiculously hard to fix them. Then we don't do it. But in this class, they're not hard yet. So we want to understand how to do this properly. So the square root of 7 in the denominator, I'm going to multiply by the square root of 7 to get rid of that radical. Because, hopefully we all know, if you multiply the square root times itself, you get a whole number. So that creates that denominator that's not a radical. But a requirement in fraction world is if I want to multiply the denominator of a fraction by any number whatsoever, I'm required to multiply the numerator by the exact same number. That way I'm multiplying by a value of 1. Multiplying by 1 doesn't change any kind of values at all. And the result on top, radical times radical, all multiplication happens underneath the radical symbol, so we get the square root of 21. Now, the most common mistake that students want to make in this case, they see a 21, they see a 7, they remember their times tables. Oh, 21 is 7 times 3. Let's reduce this thing. But this 21 is inside the radical, that 7 is outside the radical, so it must not be reduced. Also, another thing I've seen people do wrong, you just highlight this just in case you're that person and you want to try and do this. They make that square root go all the way down like that. That's also not right. So make a definite separation. I've got my top, I've got my bottom. Square root of 3, square root of 7, square root of 21 on top, radicals completely on top, over square root of 7 times square root of 7 is 7 on the bottom, whole number on the bottom, radical on top, final answer is the same. Final answer is right. And I'm going to open a calculator real quick just to show you a verification process for this. Wish I'd already done that, because now we're going to wait 13 seconds for this thing to open.
Unrepeatable 13 seconds.
It feels like 5 minutes, but it's like 13 or 14 seconds. It's kind of crazy. All right, anyway, so I'm going to clear this out. If you type in your original problem, which is the square root of 3/7, like so. Oh, by the way, you can see my setup here is like this. I think you might get the square root and like does a fraction. If you go to mode and change from math print to classic, it's what I personally am used to on these calculators. If you aren't, if you go to math print, then if I type in square root and then 3 divided by 7, like that, then it's all underneath. I prefer the square root parentheses and in parentheses. It feels like it gives me more control. And I don't have to remember to hit that right arrow to get out of this thing. But anyway, square root of 3/7 equals that. And if I type in my answer, the square root of 21, oops, maybe square root, there we go, of 21, press to the right to get out, divided by 7. The decimal approximation of both your answer and the original problem should be exactly the same thing. If they are, that means you're right. All right, so they're self-checking problems. You're in the middle of a test and you want to make sure you got the problem right. That's all you have to do. Type in the problem, type in your answer, and make sure they're the same decimal approximation. Make sure your answer has a whole number in the denominator, and then you're in good shape.